Happy Friday, 10A. Here is your objective and your do now. Somebody hit pause and do the do now silently for the next 5 minutes. All right, here are the answers to the do now. Go ahead and check your work. And here's the agenda for today. We are going to learn how to write some more names and formulas for ionic compounds, but with a little bit of a twist. The first half of the class, so during first period or third period, we're going to talk about using ionic compounds that have transition metals. And during fourth period, we'll learn how to write names and formulas for ionic compounds that include polyatomic ions. We'll talk about what those are in just a minute. You will be doing some practice problems and checking your work with the answers on this video. You should have time to start your homework on pages 5 and 6. Your homework is to finish pages 5 and 6. That's due Monday. And on Tuesday, you're going to have a quiz on writing compound formulas and names for all ionic compounds. So somebody should be ready to push pause when I say to, and here we go. So we know that there are patterns on the periodic table as far as what ions different elements make. So you know that everybody in group 1 makes a 1+ ion, group 2 makes a 2+ ion, everything in group 13, like aluminum for example, makes a 3+ ion. And then on the right-hand side of the periodic table, group 15 makes 3-, group 16 makes 2-, and group 17 makes 1-. So we're wondering about what about groups 3 through 12? I've been telling you that there's no pattern. So how do you know what ion is made, so what the charge is of the ion for these metals in groups 3 through 12? So if we leave them out, they're going to be sad. So we're going to include them in this first half of class today. So you should write this part down. Your title is Ionic Compounds with Transition Metals. The transition metals are the metals in groups 3 through 12, and then there are a couple metals in groups 13, 14, and 15, like lead and tin, that are also transition metals. These participate in making ionic compounds. And they're always cations, they're always positively charged ions, but there's no pattern for what ion charge they make. They can actually make different charges. So we use a system called the Stoch system, which uses Roman numerals to show which charge these ions have made from the transition metals. So the only thing you have to know about the Roman numerals is 1 through 6, and they're listed here. I. 4 is IV. 5 is V, and sometimes you need 6, and that is VI. So here are a couple examples. The iron ion, so iron is a transition metal, it can have a charge of 2+ or 3+. And you can't tell by looking at the periodic table what the charge for the iron ion is. So if it is iron 2+, we write the word iron, and then in parentheses, we write a Roman numeral 2. And you would say out loud, iron 2. If it is the iron 3+ ion, we write iron with a Roman numeral 3 in parentheses, and we would say iron 3. You should write down these examples. Here's another example about tin. Tin, which has the symbol SN, can be 2+ or 4+. So we write tin Roman numeral 2 or tin Roman numeral 4 to show which ones. So there's just a list of elements of these transition metals that need Roman numerals to indicate what charge they have. You should write down this list in your notebook. I'll always give you this list so that you can make sure that if you need a Roman numeral, you use one. So those elements are chromium, manganese, iron, cobalt, nickel, copper, gold, mercury, tin, and lead. So what if we have these names of ionic compounds and we want to write formulas? So we're going to do 3 examples. You should write these all down in your notebook, and then you're going to do a bunch of these on your own. So here we go. Here's our first example, is iron 3 chloride. So iron, I know, is Fe, and this Roman numeral 3, which always goes with the element in front of it, shows us that this is iron 3+. Chloride is Cl- because it's in group 17. We cross the charges, and we end up with FeCl3. So the process is exactly like the process we've been using, but we just need to use a Roman numeral to tell us what charge it is. The next one is copper, and this Roman numeral 1 tells us that it has a +1 charge. Oxide is in group 16, so we know it's 2 minus. We cross the charges, and we get Cu2O. The last one, tin is Sn. This IV, that's Roman numeral 4. That tells us that tin has a charge of 4 plus. Sulfide is S with a charge of 2 minus. It's in group 16. We cross the charges and end up with SN2S4. Now here's the catch. We're doing this one because you notice that these can be reduced. If you divide each of them by 2, you get SNS2, and that is the final answer. So what if we want to go back the other way? What if you get a formula and you're asked to write the name? We'll do 3 examples writing names, and then you're going to do a bunch of practice problems of both of these types. So write these down in your notebook. The first one, Fe2O3. I know Fe is iron, and I know that iron is one of those elements that needs the stock system to show which charge it has. We're going to uncross the charges. So that means this 3 originally went with iron, and this 2 originally went with the oxide. So that tells us that it must be iron 3 oxide. Here's another one. I know that Pb is lead, and I know that lead is one of those elements that needs a Roman numeral, and I know that I is iodide. We will uncross the charges, which means that lead must have been 2 plus, and that's Roman numeral 2. Final example, this one's a little trickier. I know that Fe is iron, which needs a Roman numeral, and O is oxide. If you uncross the charges, it looks like it's iron plus and oxygen minus. So we know that oxygen actually has a charge of 2 minus, which means that iron, in order to cancel out those 2's, must also have a charge of 2 plus. So there's Roman numeral 2. So here are your practice problems. You have these on your worksheet in front of you. Do 1 through 8. Hit pause when everyone's done. We'll look at the answers. All right, here we go on answers. The first one is copper 2 iodide. Oops. The second one is, let's see, Pb 2 plus, S2 minus. They cross. You would get Pb2 S2, but the 2's cancel, so you will get PbS. Number 3 is copper 2 bromide. Number 4 is Fe2 plus, Cl minus, FeCl2. This guy is tin. Ooh, this is one of those tricky ones. Oxygen is 2 minus, so that must mean that tin, to cancel out that 2 minus, has to be 2 plus. Lead, 4 plus, Br minus, Pb, Br4. This guy is tin, 4 phosphide, and chromium. Oh, whoops, we're writing the formula. Cr3 plus, Cl minus, CrCl3. Check your answers. Fix them if you got them wrong. All right, at this point, you can go ahead and start working on page 5 in your homework. The second half of class, we will move on to talking about ionic compounds that have polyatomic ions as part of them. So far, each ion has just been made of one single atom, like we have chloride or the sodium ion, just one single type of atom that has lost or gained electrons. So our question is, can an ion have more than 2 elements? So our question is, can an ion have more than 1 element? And the answer is yes, it can. If an ion has more than 1 element, it's called a polyatomic ion. So write this down in your notes. A polyatomic ion is an ion made of more than one element, and the whole thing has an overall charge. So for example, NO3 minus is a polyatomic ion. It is a nitrogen atom bonded to 3 oxygen atoms, and the whole thing has a charge of 1 minus. There are many polyatomic ions. You picked up a list when you came into class. You don't have to memorize these. You can use this list, and some of these are more common than others, but we're going to use some of these. In some examples right now. So first of all, naming ionic compounds with polyatomic ions. Copy down the title, and then we're going to do 2 examples. This is pretty straightforward. All right, so we're just going to write the names for these. We know that K is potassium. And if you look up on your chart, you can find NO3 minus. Even though the minus sign is not written here, this one is still called nitrate. Be careful because there's also one called nitrite, which is NO2 minus. They're easy to get confused. This is NO3 minus, so it's nitrate. This one, Ca, is calcium. And you'll find on your chart PO4 3 minus. The 3 ended up down here, but it's still called phosphate. So here are a bunch for you to name. Use your periodic table and the polyatomic ion chart to write the names for these ionic compounds. Hit pause and come back to check your answers. So let's check our answers to naming these ionic compounds. This one is sodium. Great. So now we're going to go back the other way, and given the name, we'll learn how to write the formula. So we'll do the 3 examples down at the bottom of the page. These are 3 names, and we will write the formulas that they go with. So write these examples down in your notebook, please. So the first one is sodium sulfate. I know that sodium is Na plus 1. Sulfate is SO4, and it has a charge of 2 minus. We're going to cross the charges. The 1 goes down there invisibly, the 2 is there, and we have Na2SO4, sodium sulfate. Next up, magnesium nitrate. I know that magnesium is Mg2+, and nitrate is NO3-. I'm going to cross the charges, and I end up with MgNO3 2. But the problem is that we don't want the 3 and the 2 next to each other because it looks like it says 32. So we're going to put parentheses around the polyatomic ion only, and that's the finished formula. So this says we have 1 magnesium ion and 2 nitrate ions. Last one, magnesium carbonate, Mg2+. Carbonate is CO3 2-. We cross the charges. Mg2, parentheses, CO3, 2. You might notice something that, like other ones we've done before, you can simplify this. We're never ever going to simplify the subscript that goes along with the polyatomic ion. However, we can divide both of those by 2 and get MgCO3. So here is your list of practice problems. You can do this right on your worksheet. Hit pause and come back and check your answers. All right, here we go. Sodium nitrate, Na+, NO2-. Cross the charges, and you get NaNO2. Sodium nitrate. Cross the charges, and you get NaNO3. Magnesium sulfate, Mg2+. Sulfate is SO4 2-. Cross the charges, and you get Mg2, SO4 2. Oh, the 2's. Oh, zoomed in too far. The 2's are going to cancel out, so we get MgSO4. Aluminum carbonate, Al3+. CO3 2-. Cross the charges. We get Al2 CO3 3. calcium hydroxide, Ca2 plus, OH minus. Now, there's something special about hydroxide. We are going to use parentheses because we want to make sure that we're showing that we have 2 hydroxide ions, not just 2 hydrogens. So CaOH2. Ammonium, NH4 plus, oxide, O2 minus. We have NH4, 2O. Ammonium chloride, NH4 plus, Cl minus. Oh, that's easy. NH4Cl. And finally, magnesium nitrate, Mg2 plus, NO3 minus. Mg, NO3, 2. All right, and that is it. You are going to hand in this worksheet where you did your practice problems, and you're going to start working on your homework on pages 5 and 6. That's due on Monday.